Welcome to the video on problem solving exercises. In this video, we will go over an example of Isocost line. So we have the following information. A firm has a weekly expenditure amount of, let's say, $2,000. It can spend the money for procuring two inputs. Capital, which I will denote by K, so units of capital, and then labor, which I will denote by symbol L. So if I write K, K is the amount of capital or units of capital rented, and L is the amount of labor hired. So the cost for each one of these inputs are given in the following form. First, the wage. This is the wage for labor, given as, let's say, for example, $25 per hour. I will use symbol W for wage, and then rent for the capital. I will use symbol R for capital, is given out to be $20 per hour. So that's the amount of money the firm has to pay if it wants to rent a machine for an hour. Given this, we can find out combinations of capital and labor which the firm can afford to employ. So let's write down in a table. So what I will start is, we will have some combinations of capital. I'll create a table with two columns, K and L, and we will look at what are the options available to the firm. So first, let's look at some benchmarks. So suppose firm says, I want to have all capital. Entire $2,000 is spent on hiring capital, no labor. So L is 0. Capital would turn out to be, the firm has $2,000 to spend. The rent for the machines is $20 per hour. One can see firm can hire 100 units of capital. Obviously L is 0. So that's an option which is available to the firm. 100 units of capital, 0 units of labor, and then we can go to next one where firm has only labor. All money is spent on labor. So this time I have capital turns out to be 0. The labor would be again $2,000 to spend. $25 an hour is the rent, is the wage. So one can do this calculation. You will find out 80 units of labor. So L is 80, K is 0. That's the second option. I am sure we can check that the midpoint of these two would also be available to the firm. So I will leave it for you to check that K equal to 50, L equal to 40 is also available, given the resources and the wage. So I have 50 here, 40 here. That's some information. Obviously I don't want to add many more, but we can find many other combinations of capital and labor which the firm can hire. But we have given this table enough information to be able to draw something similar to what we call as the budget line, but here we will call it Isocost line. These are all capital labor combinations which the firm is hiring is able to employ given the wage and the rent and the expenditure amount available. So what I will do is I will have K on the vertical axis, K here, L on the horizontal axis. So this is the origin, 0, 0. This is the capital, K on the vertical, and we can see we would like to plot all the points on the table which we had listed above. But we also know that if we see that the isocost line is a straight line, then we need only 2 points. That would be enough. So I will take the two extremes, 100 units of capital, 80 units of labor. These are the extremes. At 100 units of capital, there is no labor. At 80 units of labor, there is no capital. And if I connect these 2 points by a straight line, that's the isocost line. Iso means equal, cost. So these are all, any point on this straight line is leading to an expenditure of exactly $2,000, and the firm is able to hire non-negative amount of capital and labor. So isocost line, all combinations of capital and labor which lead to $2,000 of expenditure with cost exactly $2,000. That's the meaning of isocost. So I have drawn the graph. I have written the table. We can also write down the equation. For that, let's say the money spent, the firm's expenditure on the amount on the labor if it hires L unit of labor. So expenditure on L units of labor will be wage times the amount of labor, but we know wage is $25, so 25 times L. Similarly, I can also write expenditure on capital. So let me write EXP for expenditure on capital would be R times K. R is for the rent and K is the amount of machines. We know rent is $20 per hour, so 20 times K. So if I add the two, I got the total expenditure. Total expenditure which turns out to be sum of these two numbers, so 25L plus 20K, and we know the firm has $2,000 to spend, so we are looking at now the equation for isocost line. $25L plus 20K equal to $2,000. That's the equation for the isocost line. We can make this exercise more general. Suppose instead of the numerical values assigned, all we know is wage is W, rent is R, and then the cost available, the firm is going to incur is C. So let's say cost is C, wage is W, rent is R. These are all per unit, so let me rewrite R. wage is W dollars per unit of time, rent is R dollars per unit of time, then the equation for Isocost line would turn out to be W times L. This is the amount the firm spends on the wage bill. R times K. This is the amount firm spends on the rent bill, and these two added together should be exactly equal to C. That's the Isocost line. Equation for an Isocost line. I can draw this as a graph. Again, I have L on the horizontal axis, K on the vertical axis. We want to do the same exercise for finding out combinations of capital and labor which will be available to the firm, and I will start with the extreme points. So suppose first one, no labor, then the amount of capital this firm can hire is C divided by R. You can see if L is 0, W times 0 plus R times K equal to C. This is the budget line, and I get W times 0 is 0 plus RK equal to C. I can divide both sides by R to obtain the amount of capital this firm can employ, and that turns out to be K equal to C over R. So that's an extreme point. Obviously at this point we know L is 0. Okay, let's go further. So I will plot this here. This is C divided by R. Next time I will say no capital, and I would like you to see that in this situation the amount of labor the firm can hire would turn out to be C divided by W. So K is 0 here. We have C divided by W. I can now connect these 2 points. I know it's a straight line, and that's the Isocost line. Slope of the Isocost line, we will also like to compute. Slope of the Isocost line is rise over run. We know the slope here is negative. It's a downward sloping line. So I can now write down minus C over R, that's the rise. In fact, that's the fall. As we move from the point on the left to the point on the right, over the run being C over W, we can simplify this. I am dividing a quotient by another quotient, which is simplified to multiplying by the reciprocal of the quotient in the denominator. You can see, given this exercise, we are able to cancel out the cost from both the expressions. So the slope turns out to be negative W over R. So just I will write it again. Slope is negative W over R. And that's a good point to stop.